Okay, hello everyone. Let's go ahead and take a look at factorials and factorial notation. Now, the product principle is going to involve the multiplication of independent operations in succession. So what's going to happen is there's going to be times when we have to go ahead and multiply factors together that are consecutive positive integers. And if we want to do that, we use factorials, and in order to express it, we use factorial notation. So it says for n is greater than or equal to 1, n factorial is the product of the first n positive integers. So n factorial is going to be equal to n times by n minus 1 times by n minus 2, and so on until we get to 3 times by 2 times by 1, ending at 1, of course, because that's the smallest positive integer. So if we wanted to go ahead and write 5 factorial or expand 5 factorials, we have 5 times 4 times 3 times 2 times 1. 3 factorial is going to be 3 times 2 times 1. Now, what if we didn't want all of the integers that are less than a particular value? And let's say, for example, we only wanted 1 or 2 or 3 or 4 of them. So let's just take a simple example here and say, what about 5 times by 4? Well, if we go ahead and look at 5 times by 4, we can actually write this differently using factorial notation by saying that that's the same thing as 5 factorial divided by 3 factorial. And why is that true? Of course, because we have 5 times 4 times 3 times 2 times 1, 3 times 2 times 1 in the denominator. And of course, being that all of these are factors, we can go ahead and cancel the common factors, and of course we're left with just 5 times by 4. So it's going to be very important for us to recognize that when we go ahead and expand the factorial, we have factors, and oftentimes there's going to be common factors, and because of that we can go ahead and cancel them. Now, it's going to be important also to recognize this particular property for that particular fact. Okay, if we take a look at n factorial, that's the same thing as writing as n times by n minus 1 factorial. Basically what we're saying is that here's the n, say for example, and then all of this here can be represented as n minus 1 factorial. So it's the same thing, it's just different, it just looks different. And we could also go ahead and rewrite it this way, n times by n minus 1, and then times by n minus 2 factorial. Now, let's go ahead and take a look at an example of how we can use this particular principle, well maybe this fact, let's just say, to go ahead and simplify something that is very algebraic and involves factorial notation. So notice how we have n factorial here, and we have n minus 3 factorial here. What we're going to have to do, of course, is we're going to have to expand it to find out where our common factors are. And then once we find out where all those common factors are, we can cancel them out and simplify the expression altogether. So notice that we have n times by n minus 1 times by n minus 2 times by n minus 3 factorial. And the reason why we do that is because we have the n minus 3 factorial in the denominator as well. So now we can cancel out all of those factors. Of course, I'm not going to write all of them. Cancel out all of those factors, and I can simplify this to just n times by n minus 1 times by n minus 2. Okay, so we know that we can use it to cancel common factors. Now, the one thing that we didn't mention is, well, okay, if this is for n greater than or equal to 1, what is 1 factorial? Okay, 1 factorial is actually just going to be equal to 1. There you go. Now, the thing though is that if we go ahead and extend this a little bit, it doesn't say anything about 0 factorial, which oftentimes does appear. So we're going to have to go ahead and try to define it using this particular recognition, this particular fact here. Now, take a look and just follow the logic. It says if we have 1 factorial, now we just said that 1 factorial is just going to be equal to 1. So it's going to be equal to 1 times it by 0 factorial, because of course this property here, because 1 factorial is going to be equal to 1 times by 0 factorial. Now, if we take a look at both sides of the equation, this is 1 times by 0 factorial, so that means then that 0 factorial has to also be equal to 1. So be careful about that. 0 factorial is not equal to 0. 0 factorial is equal to 1. Okay, so let's go ahead and summarize. We said that oftentimes we're going to need to multiply positive consecutive integers. In order to do that, we're going to use factorial notation, and we can represent it as such here. And it's going to be important for us to recognize that all of these are common. There's going to be times when we can cancel out common factors. And in order to do that, we need to sometimes go ahead and expand our factorial notation so that we can actually see where those common factors are. Okay, so we'll go ahead and take a look at this in class. We'll see how you do, and see you the next time.